Welcome to my YouTube channel How Super Maths. Today we will discuss very important topic of partial differential equation, and in today's solution, the solution of linear partial differential equation with constant coefficient contains two most important part, that is complementary function and particular integral. So let's see the different cases of complementary function and particular integral. So there are different cases of complementary function. First case, case 1. If roots are real and different, say m1 and m2, that is, if we have partial differential equation and after obtaining the auxiliary equation, if we will get two distinct roots, say m1 and m2, then complementary function is given by phi1 of y plus m1x plus phi2 of y plus m2x. Recall that in first year in ordinary differential equation, the formula for CF is C1 e to the power m1x plus C2 e to the power m2x. But here in partial differential equation, we will use function phi1 and phi2. So here phi1 of y plus m1x and phi2 of y plus m2x is the required complementary function if roots are real and different. Now case 2, if roots are real and equal, that is if m1 equal to m2 equal to m, then complementary function is given by phi1 of y plus mx plus x into phi2 of y plus mx. As the roots are repeated, we will multiply by x in second function. Now case 3. In case 3, for a distinct imaginary roots, that is if roots are m equal to a plus minus bi, that is first root m1 is a plus bi and second root m2 is a minus bi, then complementary function is, it is simple, phi1 of y plus m1x plus phi2 of y plus m2x, where m1 is equal to a plus bi and m2 is a minus bi. Now let's see the formula to find particular integral. Consider the partial differential equation of the type f of dd dash z equal to f of x comma y. So here in this partial differential equation, z is dependent variable which depends on variable x and y, that is independent variable x and y, and the partial differential equation is of the form f of d dash z equal to f of x comma y, where d stands for del by del x, d dash stands for del by del y. Then pi has formula 1 upon f of dd dash into f of x comma y. Now let us discuss the first case of particular integral pi. That is, in a right hand side of equation 1, if f of x comma y is equal to e to the power ax plus by, that is first case for exponential function e to the power ax plus by. Recall that in first year we have to replace d by a in such case, but here in partial differential equation there are d as well as d dash. So here what we have to do, we have to replace d by a and d dash by b in order to get the particular integral. So pi is equal to 1 upon f of a comma b into e to the power ax plus by, that is replace this d by a and this d dash by coefficient of y, that is b. If f of a comma b is equal to 0, that is if this denominator gets 0, then in such case fail, then we have to find particular integral pi in this way, that is we have to multiply by x and differentiate f of dd dash with respect to d. So we will get f dash of AB. Okay, what we have done in PI, multiply by x and differentiate these f so that we will get f dash, and then replace d and d dash by a and b into में e to the power x plus by as it is. Okay, comma f dash of AB should be non-zero. So here denominator should be again non-zero. If in next step we will get f dash of AB is equal to 0, then again case fail, and in that case again we have to multiply by x and so on. In this way we will find the particular integral. Now let's see some example based on these cases. Now let's see the solution of this partial differential equation. In this differential equation, let d equal to del by del x, d dash equal to del by del y. That is, we have chosen the notation capital D for del by del x, capital D dash for del by del y, and d dash equal to del 2 by del x del y. Therefore, given equation 1 becomes d square z plus 2 into dd dash z minus 8 d dash square z equal to e to the power 2x plus y. That is, this equation can be written as d square plus 2d d dash minus 8 d dash square into z equal to e to the power 2x plus y. Say equation number 2. So that is our given partial differential equation. Now in order to find the solution, we have to find its two parts, that is first one complementary function and second particular integral. Okay, so in order to find the complementary function for auxiliary equation, for complementary function we will first find auxiliary equation, which is obtained by putting d equal to m and d dash equal to 1 in f of dd dash equal to 0. That is, we initially we will equate f of dd dash to 0 and then replace d by m and d dash by 1 in complementary function. Okay, for complementary function. So we will get auxiliary equation. Auxiliary equation is m square plus 2m minus 8 equal to 0. From this f of dd dash equal to 0. Okay, therefore after factorization we will get m plus 4 into m minus 2, it is equal to 0. Therefore m equal to minus 4 comma 2 are the required roots of auxiliary equation. Therefore complementary function CF is given by phi 1 of y plus m1x plus phi 2 of y plus m2x. Since roots are real and different, in this case roots of m are minus 4 and 2, that is m1 equal to minus 4 and m2 equal to 2. So roots are real and different, therefore complementary function CF is equal to phi 1 of y minus 4x plus phi 2 of y plus 2x. Say equation number 3. Now we have to find second part, that is PI, and we know that formula of PI is 1 upon f of dt dash into f of x comma y. So here 1 upon f of dt dash. What is f of dt dash here? It is d square plus 2d d dash minus 8 d dash square into f of xy, that is in right hand side it is given as e to the power 2x plus y. Now as it is exponential function, we will consider it as case 1. And in case 1 of pi, we have to replace dy a and d dash by b, where a and b are coefficient of x and y in exponential term. So here d equal to 2, d dash equal to 1, therefore pi equal to 1 upon, now it is 4 plus 4 minus 8 into d dash square, that is 1 into e to the power 2x plus y as it is, which is equal to, so here 4 plus 4, that is 8, minus 8, which is 0. So 1 upon 0 e to the power 2x plus y. In a denominator we have obtained 0. Therefore here case fail, and if case fail, then in order to find pi, we will multiply by x into 1 upon and differentiate these d square plus 2 d dash minus 8 d dash square with respect to d, that is del by del d of d square plus 2d dash minus 8 d dash square into e to the power 2x plus y, and then replace d and d dash by ab. So it is 1 upon, now it is 2d plus, with respect to d, derivative of 2d d dash is 2d dash minus 0 into e to the power 2x plus y. Now after differentiation we can replace d and d dash easily. So it is x into 1 upon, now 2 into, replace d by 2 and d dash by 1 into e to the power 2x plus y as it is. So it is x upon 4 e to the power 2x plus y. Say equation number 4. Therefore required complete solution, that is general solution, is CF plus PI, that is from 3 and 4 we will get the required solution. Therefore complete solution is Z equal to CF plus PI, it is equal to, from equation 3 CF is phi 1 of y minus 4x plus phi 2 of y plus 2x, and plus pi from equation 4, it is x upon 4 e to the power 2x plus y. See equation number 5 is a required general solution of given partial differential equation. Now let's see another example based on this topic. Example 2. So all these three examples are of the type 1, that is exponential function. Okay, so these examples are homework for all of you. Case 2 for pi. Now if PD is of the form f of dd dash into z equal to sine of ax plus by. Previous case was e to the power ax plus by. Now in case 2 there is function sine of ax plus by or suppose cos of ax plus by. In this case pi is equal to 1 upon f of dd dash into sine of ax plus by or cos of ax plus by. So in this case for pi we have to replace d square by minus of a square, d dash square by minus of b square and mix d dash by minus of ab. Let's see one example based on case 2. So in this example there are two cases. In right hand side it is e to the power 2x plus 3y plus sine of x minus 2y. So initially we will apply case 1 for exponential function, and for sine function we will use case 2. Okay, so let's start. Here d equal to del by del x, d dash is del by del y. Now auxiliary equation of equation 1 is m square minus 3m plus 2 equal to 0, since d equal to m and d dash equal to 1. Therefore it is m minus 2 m minus 1 equal to 0. Therefore m equal to 1 comma 2, that is roots are real and different, that is m1 equal to 1 and m2 equal to 2, and roots are real and different, therefore its complementary function CF is phi 1 of y plus m1x, that is 1x, plus phi 2 of y plus m2x, that is 2x. So equation number 2. Now we have to find pi. So pi is equal to 1 upon f of dd dash. So f of dd dash is here d square minus 3d d dash plus 2d dash square into f of x comma y. So in right hand side function is given as e to the power 2x plus 3y plus sine of x minus 2y. Now let us break these two parts. So it is 1 upon d square minus 3d dash plus 2d dash square into e to the power 2x plus 3y plus 1 upon d square minus 3d dash plus 2d dash square into sine of x minus 2y. Say pi1 plus pi2. So in order to find the pi, we will separately find pi1 and pi2. Now pi1 is equal to 1 upon d square minus 3d dash plus 2d dash square into e to the power 2x plus 3y. So replace d by 2 and d dash by 3 in first case. So it is 1 upon 4 minus 3 into 6, that is 18, plus 2 times d dash square. So d dash square, that is 9 into 2, 18, e to the power 2x plus 3y as it is. So it is e to the power 2x plus 3y upon 4. That is our pi1. Now to find pi2, there is sine function, and pi2 it is equal to 1 upon d square minus 3d dash plus 2d dash square into sine of x minus 2y. Okay, now compare this sine function with sine of ax plus by, so that we will get a equal to 1 and b equal to minus 2. But for sine function, we will replace d square by minus of a square, dd dash by minus of ab, and d dash square by minus b square. Therefore, here d square it is equal to minus of 1 d dash equal to minus a into b, that is 1 into minus 2 that is plus 2, and d dash square is minus b square, that is minus 2 का square, that is 4, that is minus 4. Therefore, pi2 it is equal to 1 upon, now d square is equal to minus 1 minus 3 into dd dash, that is plus 2 into d dash square, which is minus 4. Sine function as it is, which is equal to 1 upon, now it is minus 1 minus 6, that is minus 7, and minus 8, minus 15 sine of x minus 2y, and that is our pi2. Therefore, complete pi is equal to pi1 plus pi2, that is e to the power 2x plus 3y upon 4 minus 1 upon 15 sine of x minus 2y. Say equation number 3. Now complete solution is CF plus PI. So from equation 2 and equation 3 we will get the general solution. So general solution will be, general solution is equal to CF plus PI. Therefore general solution Z equal to CF. So CF from equation 2, it is phi 1 of y plus x plus phi 2 of y plus 2x plus pi, and pi is e to the power 2x plus 3y by 4 minus 1 upon 15 sine of x minus 2y is the required solution. So in this way we have seen the how to solve partial differential equation of type 1 and type 2. Write down homework, that is example for practice. First one, solve del 3z by del x cube minus 7 del 3z by del x del y square plus 6 into del 3z by del y 3 equal to sine of x plus 2y. And this question is very important.